Hello, hello, hello. Am I alive? Am I alive? Am I alive? I think I'm alive. I am alive. Okay. Oh, hello? I think I'm alive. Okay. I am alive. Hello. Do you hear? The math guy who made 30 videos and just stopped there. And now I'm like, yeah, I'm just making a stream now because I don't know, nothing to do. I have free time. That's certain. I have free time right now, and I'm using it to my advantage to stream. And here you have, okay. I have some plans for the stream today. Like, you know, who plans their stream, you know? Who even plans it? But yeah, I did say it's unprepared. It is unprepared. But yeah. Let's see. So I'm just I ponder about some stuff, reflective stuff, and one of those reflective stuff is what's the arc length for Parabola? Well, that's just out of the air that I just said that, but I'm planning to find the arc length for Parabola on Desmos, and while there I'm just gonna do some, you know, elevate the dead air, if that makes sense. Yeah, hold on. I'm like taking care of like two things at the same time. So hold up. Okay. Let's see. Okay, we're all set. Let me just draw a simple parabola. Let me do what the first thing my mind tells me when I say parabola. Okay. So a times x minus b squared plus c, the usual. Okay. If I plot the point BC, I can move this around because B is the horizontal, C is the vertical. Yeah, that's that. And A is just sure. I don't know what the right sound effect for this, but just up or down, stretch or amplitude or whatever the right word is for what A does to the parabola. Whether stretches or compresses. Yeah, right, there we go. Thank you, brain. Okay. And what I want to do is find the arc length of this. Okay, so I'm not actually going to use this formula for the arc length because one of the ways to find the arc length is with a given base and a given height, right? And there has to be some way I can translate this into base times height parabola. But yeah. Okay, let me scrap all these away. Let me find a new formula for parabola that expresses base and height. I don't know. I want let's say one parabola that's like on the first quadrant, just the first quadrant. Let me do the base parabola first. Okay. And you know what? I don't think I'm teaching, like I'm directly teaching, so I'll find my own way to solve it. So let me just flip this because I don't know. I just feel like flipping a parabola. It's all. And this is like, you know, you're throwing an object. This is the trajectory of an object being thrown, like I don't know, infinitely from the from the bottom of the Empire State Building and then drops down in like 50 seconds. I don't know, but yeah. So let me locate this to the first corner. Let me just move this a little bit. Just two. Okay, I want it to corner on 0. What is 0.586? Yeah, hold on. Let me 0.586. Oh, let me go into my own edit for a bit. No. Holy shit. So by the way, this is how I solve problems. I just type the equations in Desmos and then boom. And then I just do the algebra in the expression fields, you know. Then plus 2. Okay. What? Minus square root 2. Oh, okay. Okay. Anyways, let's let me just position this so it's like on the corner of the freaking thing. There we go. Okay, so it's stationed at from 0 to 4, and like, okay, I want to find the arc length of just this thing below here, just this part here. I want to do that. So, okay, it's a parabola from 0 to 4 with translations, something. Okay, so what's the arc length of this? Okay, so you know, the arc length, it's the integral from 0 to 4 of this is a joke, by the way, prime x squared dx, and there we go, we have our arc length 9.293567. There we go. End of the stream, guys. Thank you for watching. But okay, no, of course not. But yeah, like I said, the arc length of this is from which intervals are you taking the length of, which is from 0 to 4. And you need to memorize like the arc length formula. I've did like one video of the arc length formula for it. It's on the so basically video. One of them has it, but it's basically into this form, right? It's this one. It's integral of something, square root 1 plus f x squared dx. Yeah, and then you just define the bound. So it's from 0 to 4. This here is just like by memorization. Like you have to, well, you can memorize the arc length formula, but if you really want to like get it stuck into your head, you need to like know how and why this formula is like this. You know what I'm saying? But yeah, but this most immediately tells us the answer of the thing, but I don't like that. Oops. Most problems for it. So what I do, this is just a habit of mine. I just copy paste the thing down and replace the variables. Just arrive at a specific answer for this, right? So this is just f of x, but I need like f from fx. So let me integrate that. So it's this line over here. Okay, so this is f prime x, but what is f prime x, right? So I just take the derivative of this. So real quick, it's -2 times x minus 2 from 0 to 4. I'm not gonna write the interval. I'm lazy. Okay. Okay, so this is the interval, right? Since it's the f prime x, I just replace this guy and boom. And okay, so you can see we have the same number appearing, but instead we have like a more specific formula for it, right? And now I try to, you know, just try to make this, like simplify it, and the end goal is just try to find like a single number, like a numerical exact number that represents 9.2935 by like doing algebra from this, right? Okay, so let me just copy this field over. And okay, so it's gonna be 4x minus 2 squared. Okay, same thing. That's just the square of that. And I don't know, should I expand this? Or no, I could just change the bounds. I think people can do that. You can change the bounds of the integral if you know how it works. Basically, just plus 2 this field over here with the x. So boom. And what do I do? I add a plus 2 on these. I think you add a 2. No, you don't. You minus a 2. Minus 2, minus 2. There we go. So basically, we just have this. And hey, what we've basically just done is, like that minus 2 there is just pretty much useless, because in the end I just translated it into the bounds of the integral or something like that. You know, the big problem is, how do I solve for this bullshit here? Oh, I don't know. Let me change these for a bit. Yep. Okay. And that's where, well, let me do some more simplifications. Hold on. 1/4, 1/2. 4 plus 6 squared. What was it? Hold on. Let's factor 4 of these. Oh, that's right. Okay. Oop. 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 Okay. This is the same thing. The 2. Alright. So this is where all hell breaks loose, because then is when you need to use integral strategies to solve for this. Like shit, man. One of these strategies is define, I don't know the expression. Define some variable a. Okay, what you press enter for that? Come on. Equals equals like 1/2 tangent. Is it, well, what was it? Probably no. X equals 1/2 tangent a. I think that's what you did. What I remember doing. And you do some sort of chain rule for this, if you know what chain rule is. If not, then sorry. And you replace this entire bullshit with the x. And now you notice that the dx is incompatible with the a here, so we need to find the dx, like the, what was the word? Differentiate. Oh, and by the way, this one does not like, it's not used for like algebra purposes, but I'm doing it anyway because it's what school told me. What can you do? I was gonna take the derivative of this. Secant squared. Okay, derivative of tangent secant squared, right? I remember that. Okay. I hope this is right. So what I do next is, here we have the dx, and take this and replace it with that. Okay. Oh, that's right. We have to change the bounds as well. So if x is 1/2 tangent of a and something something. Okay, this is like replace x with 2 and -2. So 2 equals 1/2 tangent of a, and do some algebra. Tangent of the inverse tan of 4. Okay. So a lot of steps so far. So the x, the dx, and the bounds, the 2 bounds. So that's 3 to 4 steps you have to do when doing this sort of simplification. I don't know what I'm trying to do in this stream. Like, am I teaching you, or am I like just doing stuff on my own? I don't know why I'm asking myself that, but okay. Let's see. Arc10 of 2. Let's see. Is there an arc10 of -2? Yeah, there is, right? Okay. I think it was 4. No? Okay. Okay, we have the same value. Just to say that this thing is the same thing as this. Okay. Alright. That's good. That's good. Alright, let me do some simplifications here and there. Yep. Yep. And okay, this one here. So the reason I put 1/2 tangent of a here is so that when I take the square of this, so it's gonna be 1/4 tangent squared. Okay, still the same thing. So the reason I put it is that so that this happens in the square root. There's a 1/4 plus 1/4 tangent squared, where in it I can do this 1/4 1 plus tan squared of a, right? And hey, look, tangent of square plus 1 is just secant squared. Let's see if I can remember that. Okay, there you go. Same thing, right? There you go. And let's see. So this thing here, we can now like unsquare root, just evaluate this thing, the square root, which is just gonna be a 1/2 secant. Okay. Okay. So far so good. And I can see that our secant is like a cube here. And shit. So now we have 1/2 secant a cubed. And secant a cubed is gonna be way ugly. Okay. Let me remember how I solved this. Let me challenge myself. How did I solve the secant a cubed? Okay, let me go on my own tangent. No pun intended on how to solve this. Okay. Secant x cubed dx. Okay, how do I do this? I remember in like integrals, you have to do. There are multiple strategies on how to find the integral. Like I remember the teacher. Like his advice was, can we solve this? Or have we tried all the possible options to solve for it? And I like how he just breaks it down as like, hey, can we solve this? Can we? I mean, is it possible? You know, like, is it not possible? Do you think so? It's like there's some motivation in those words. That's just, oh man. So it's like it shapes the integrals as some. Hello, cat. Oh, Charlotte. Yeah, the cat is meowing. Maybe she's hungry. I don't know. But it's like it poses integrals as a challenge instead of like your regular homework problem, where it's like try to find try to find the integral for secant x cubed. And tell you what, we encountered this problem once. This one integral, and it took us like an honest, 30 minutes with like the entire keyboard occupied of strategies on how to solve the secant x cubed. And that's the moment where I have to remember, maybe remember that moment when we tried to solve it, where to the point I'm doing it again. I just hope I spend less than 30 minutes on this one integral. Oh, okay. So one strategy, let me try this. 1 secant x times secant squared x dx, okay? Now, let me do integration by parts. So I'm gonna... I have a different strategy for integration by parts if you know it. But, basically for my case, I just, well, hold on. Let me make this like the u, I think. I don't know. Like secant squared x. And then the integral of... Nah. Okay. I think I've met it. Okay, let me write it down. I'm assuming that this is gonna be like... Okay. So, ln... So this is the integral of singular secant x, right? Secant plus... What are we doing? Plus tan of x. Okay. Alright. That's why I said this is an unprepared stream. Expect some bullshit from the... Holy shit, did they close my window? God damn it. Okay. Am I live? Am I live? Yeah, I'm live, I think. Something in my throat. Don't mind it. Okay. I think stream quality is decent. I mean, everything is still... come on. My fucking throat. Man. Okay. Where were we? Alright, we were... Integration by parts, okay. So, copy down secant squared and take the integral of this guy, right? Minus the integral of... Minus the... What was it? Get the tangent of this? The derivative of this. Well, that's 2 secant x tangent of x secant of x plus times, okay, hold on, times the integral of this guy dx, and this is supposed to be like evaluated like this part here. Hold on. From 0 to 1. 1, 1, 1, minus 0, 0, 0. Okay, same thing. Now, question is, can we solve this? Okay, we can simplify this if you want. We can take 2 secant squared here and Well, okay, wait, hold on. Something's wrong. Oh, okay. And okay, we have this expression here. This one's a number. Just we don't have to necessarily find the number of this, but can we solve this integral here? That's what I remember what the teacher said. Can we solve this? Well, I mean, we can go further and try to find the integral of ln of absolute value of secant plus tan. But personally, I think I'm just gonna stop there and go back to the drawing board, where okay, we did one kind of integration by parts. Let's do the other one, right? So this time we're gonna integrate this guy. Let me remind myself. Let me put some personal notation. Okay. Don't mind line 13. That's all right. So this time we're gonna write down the secant x and multiply it by the integral of secant squared, which is 10. Okay, close enough. And minus that with let's see, let's see, secant x, the integral of this guy, right? No. Derivative of this, which is like tan sec times this guy, integral of this. Okay, this here is supposed to be like evaluated from bounds, so let me just write that down. Oops. Okay, same number. We know this is defined, but can we solve this? Tan squared x. Okay. Okay, I'm about to sneeze. Okay, the sneeze went away. Okay, can I solve this? 10, 6. Well, let me go on from here. Let me try to solve this thing here. So what can I do to solve this? Let's see. N squared secant. Okay, let u equals tangent of x. Then du is secant squared x. Let's see what that is. Actually, hold on. Scrap that. What if I do this? Here we go. Identity time. Yeah, tangent squared is equals this guy times this. Alright. Let's see. Well, let me see. What I can do is come on. Distribute. Took me long enough to figure that word out. Minus this guy. And close that. Oop. Oh shit, you can't do a cube on the side. Okay, this guy. Well, okay, reality check. We're trying to solve for the integral of the arc length of a parabola, just so you know. And we're in the integral part, so you know. Yeah. Okay, so we have this now. And let me separate this person here. The number is a person, I guess. Okay. So we have some number minus the integral of secant cube plus the integral of secant x. And, well, it seems like we have gone into a loophole, not a loophole, a loop. Because, hey, we want to solve for secant x cubed, but we have a secant x cube integral, again, over here. So, are we stuck? Should we go back? Well, let me write this out. This entire integral is equal to this guy, right? Yeah. So, this here is equal to that, right? And we can... Okay, I don't want to do this in Desmos. It's just gonna say a warning sign. Or it doesn't, it just doesn't say anything. But this entire business here is equal to this other business here. And as you can see that this right side secant cubed has a minus on it. Meaning we can plus this to the other side. So plus this integral, right? So it looks like this, right? So, wait, what the heck did I do? Oh, I forgot. The cube and the dx was left over. Oh god. Okay, so we have this, right? Okay, let me check if I... Okay. And hey, look. We have two of the same guy. Same guy, right? Just... That's all you have to know. They're just the same person, same individual, same set. And, okay. These are two of the same guy, so combined like terms, it's just 2. No, 2. Okay. And hey, here we go. Look. We have 2 integral 10 secant cubed x dx equals this sum number plus the integral of secant x. Now, question is, can we solve this? Well, it turns out that we have an integral for secant, and we have a number, and we have a 2. We could just put this 2 and like half all of these, you know. And look, what we're trying to achieve is solve for this, and now we have an entire defined thing for secant cube x. And, well, we just integrate this piece of shit here, and it's ln secant x plus tan x with the bounds of these guys, right? Hold on, look, let me put this down, right? So let me define the bounds. Let me do the thing here. From 1 to 0. How long has it been since I've streamed? It's like a year? A fucking year? Like 1 or 2? How many months, man? But okay. So let me... So it seems like, as it is written, this secant cubed here is equal to this entire expression, right? It's the same number. Thus we have this thing here. And here we go. We have an expression for secant cube for an improper integral from 0 to 1. So the reason I wrote it as an improper integral is so I can maintain some equality, some visible equality from Desmos. Some what's that word? Feedback? Here we go. So if I just like define like the improper integral, I just well, it's just the same thing as x and 0. This is gonna be x, 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 x. Okay, should change the bounds of these. Oh yeah, and improper integrals are just... Wait, no, they're not improper integrals, they're definite. I'm getting things confused. So in indefinite ones, they place these guys, right? Okay, here we go. Okay, Okay, let me explain that later. Let me remove these guys. Let me simplify this for a bit. Okay. Oh shit. This is right. Yep. And so we have a freaking integral for the secant. We have an expression. And nodders, if that's what the Zoomers have been saying all day. Okay, so we have an improper integral for this thing, right? All right. Look at all this work. So let me take all of these away, and let's go back to our original problem here, right? Boop, boop. Okay. So essentially, we now have an expression for this. We could just replace this entire thing with oh shit. Let's see. Let's evaluate this integral here. Well, okay. Ignoring the bounds for a bit. This is just replace this entire thing with just act with A's. I think A's. Yeah. Well, okay. This is just a simple like substitution. Now that we have a formula for this, I'm just wrapping my head on how to do it. Okay. Something like this. And okay, this here, the integral of that is resembles this guy, right? And okay, this is the integral. Now, for if it were definite, keep by 1/2. Forgot that thing. If it were that, okay. All right, just the bounds. My mind is still wrapping around on the next step, which is to me is close to obvious, but my mind just can't connect the obvious things together. I don't know if it's obvious to you, but the obvious thing I mentioned is just replace these guys with arctans, right? With these bounds, right? Actually, hold on. What's the secant of arctan of 4? So what the heck is that? It's this business. Right. Okay, let me solve for these, right? Let me find a number for this. I believe this is also cosine of arctan 4. Yeah. And this is cosine. Let me change this a bit. Okay. Shit. Now I need to imagine a triangle where I have to evaluate this, right? And I need a freaking diagram for this. I'm used to making diagrams just to solve for this bit here. Fucking hell. Okay, so I'm just gonna draw off screen of what this looks like. Was it? Boop. 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 This square root of 17. Okay, so okay, to the point this is square root of 17. I did some off-screen math. Okay. Hold on. How about arctan of -4? Is that like the same thing? It's the same thing. Okay. Let me check my math. Should have a minus. Oh, I'm checking my numbers for a bit. What the heck? Okay. Alright, so secant. So any secant of. Let me plug these down. Boop. 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 Come on now. Okay. Same thing. Still. Okay, now let's put things in. This guy is just root 17. Okay, let me place every sec arctan of any kind into root of 17. And okay, one more over here. Alright, now what's the tangent of arctangent of 4? Well, by golly, I wonder what that is. It's 4. And okay, this one. Actually, shit, is this -4? Okay, now I'm a freaking moron. Is this -4? Yeah, it's -4. Okay, you just copied down the same thing, I think. Boop. Alright. And what now? Oh yeah, there's a 1/2 on the very. Yep. Oh shit. Okay. I put a 1/4 in each of these. Oh, and there's still a 4 over there. Cool. Very, very cool. Okay, this one. Alright, now all I have to do is simplify this. -4. Okay. Let me use this thing here. Okay. Okay. Ellen rules. Okay. Yeah, let me do something freaking stupid. This is a 1/4 here. I just... Hold on. No, where was it? Where was it? God damn it. Where was it? There we go. Yeah. Okay. Hell yeah. Technically, right? You know, technically. There's a 1/4 in the back end. Yeah. I like to make my expressions disgusting sometimes. Oh, and here's 4 and -2, 4 and 1/2. Let me fix that. Oh fucking K! Look at this. The answer of this entire BS right here is 2 times the square root of 17 plus the ln of the 4th root of the absolute value of square root of 17 plus 4 over square root of 17 minus 4. There we go. Slap that knee. You deserve it. Okay. Let me erase these. And there we go. Okay. You finally found our answer. Let me remove all this bullshit here. I'm just gonna remove everything but the... Hold on. Okay, yeah. Here. How much time did that take? Okay, 44 minutes plus the time before I crashed. Holy shit. Okay. Well, now. Yeah, what else can I say about this? So the arc length of this piece here is this guy. Oh yeah. Now let's generalize. It's fine. Let's be good in here. Let's erase everything. Yeah, that's commonplace to me. Let me start over. Let's generalize the thing. You know, what if it's just a general parabola with I mentioned with the base and the height. So it's You know what, let me situate my... Let me draw negative parabola and put it up a bit. Okay, so some parabola. So it's at a height somewhere. The height is... The height is this guy, right? This is the height, yeah. This is the height. And if I were to bound this from 0 to 1, well, no, from where it ends and where it starts, this is gonna be... What was it? I think it's square root of h. With all algebra aside, I mean. Okay. So this business here. Hey. Shoot. Okay. Oh, how about the base? How about the base? Base. Huh. I'm trying. Let me tell you, I have a 25% of a clue of what I'm doing, and I'm trying to situate a scenario where it's. Okay, let me start over. What if I have some parabola x squared plus b? Right. Just any general like vertical translation and a vertical amplitude, right? Okay. Bruh. You know what? I'm just like, what's the word? I'm just stuck. Like, I don't know what's the right word for it. Like, I just want to express it as a negative parabola with the bounds of where it hits 0, so it's easier, right? Okay. So I think that this b is still going to be an h no matter what you do, right? But the problem is, what's the base, though? I want a given base and a given height. And the base is this, for sure. Okay, let me do another variable. Okay, what if the base were 10? Like this was 10 wide, then a is gonna be this. Okay, it's when one side reaches 5 over here, right? So something like this. So there exists some sort of algebra between the base and a, so that it stretches it. Let's see. Okay. How do I do this? I want a parabola equation such that we have a base and height without the a here. Huh. Well, I want one sort of 0 to be like this. Well, let me ponder about this. How do I do that? Oh, alright. Okay, so we have a 0 of this, which is this, right? But the value of this, of the x value of this, is half the height, half the base, right? Something like this, yeah. This is the value of x, 5.045. If I plug in, let me just test this out, 5.045. It's gonna be 5.045 squared. It's gonna be a 0, right? Okay. And this is 5.045 is just half the base. Therefore, replace x with b over 2. Got it? Okay. And we solve... Okay, what do you have? We express a as in terms of b and h, right? Okay, well, let's do that. And Okay. Base squared over 4. Okay. It's 4h over b squared. Okay. 4h over b squared. Let me do that. Okay. And there we go. And now we bound this, limit it. Wow. I gotta mess with words for a bit. Okay. So the bounds is negative b halves, right? To base halves. And I can get rid of this a, get out of here. And I can do it like this, right? There you go. And the height is same as ever. Okay, let me change this so it's only positive numbers. I detest negative 10 to 10 intervals for my base and height. Nobody likes that. Okay, so we have a discernible, a more direct expression of the parabola in terms of base and height. Okay, cool enough. Now what's next? Oh yeah, find the freaking integral of this from negative b halves to b halves. Okay, let's do that. From negative b halves to b halves of, let me write this as f of x, and then squared 1 plus f prime x squared. Okay, the usual formula, right? Okay, I plug this as f of x. This is now a function. And now I plug things in over here. Okay. So the arc length of this is 20.951. Okay, we can change this. It will change as well. Alright. Yeah. Okay. Now, let's see. Let's do the same freaking thing all over again. Let's do and f prime x. Okay, it's gonna be f prime x is gonna be negative 8h. Okay, expect to be very problematic in pronouncing that, but okay, 8h over b squared x. Okay, here we go. So they're the same thing, right? Okay. And let me copy this down. And yep. Okay, same thing. Algebra. Let me expand this. So it's 64h squared b to the 4th x squared. Okay. And okay, if I change things, it's okay. They all change the same to the same number. Okay, cool. Now, what's next? What if I factor in 64h squared b fourths like that? Okay, I just did like there's just one here, and let's see. I just extracted this guy from this. So if I do that, then this business here is gonna be h over b squared, right? Yeah. And this guy is gonna cancel with this. Whoops. Oh. And this is just gonna be, well, it's this guy. Okay, and simplify this. It's gonna be a b fourth on the top. Okay, cool. All right. All right. Oh what? I'm doing this impromptu. Just to remind you, I have no clear direction of this. So what's next? we solve this with like just a regular like defined numbers constant, but now we have like constants, variable constants, or whatever you may say it. Okay, so for the strategy, it involves something like x equals a tangent, some number tangent of some other constant. This is what I did, right? A is the variable you're gonna integrate, and a last time was 1/2, but a is gonna be something related to this, and big A. Okay, I think it turns out to be just a square, just this guy. Something concerning this guy, right? So what if I just do this for now? Okay. So that's that. If I replace this with a squared, right? Then okay, this guy is just the reciprocal of a, so number a, right? And let me put this on top so I can remind myself. Oh, okay. So we just have an expression devoid of p's and h's with just one single letter. And okay, x. Now we replace things here. Let me go on new field for this. So x equals a tangent of a, small a. Okay, you know what? Let me change this to b, because I don't want to refer to the same variable twice, you know. Okay, oop. Okay, we're still good. So b tangent of a is gonna be this guy over here. Yeah. And we have to integrate this guy. Oh god. B secant squared a. I think. And then dA. Let me check. Yeah. Seems legit. Let me place that. Okay, what else is I expect to match? Alright. And yeah, that's step 1, step 2, and then step 3 and 4, which is the bounds. Okay. So we let x equal to small b. Fucking hell. Let's change this to a c now, because we have a b on the run. Haha. Kill me. That's like, I don't know, when's the last time I said kill me in an embarrassing moment? Damn it, that's like the Undertale years of the internet. Of bleach drinking and cringe compilations. You know that? Coming from a guy that just wants to solve the arc of Parabola. The one thing he says is cringe compilation. Oh, fuck. Oh, okay, hold on. I was gonna rub my hands with alcohol, then clap my hands, and it shot onto my eye hole. Okay, never mind the Undertale talk. Let me get this straight up with. Okay. So since we replaced x with c tan a, we replace x with b halves, right? Yeah. And then we solve for okay, we do this in terms of a, I think. Do this and arctan of b of dc. Okay, that's one thing there. Now how about negative b halves? That's just the negative thing, negative part, right? Okay, if I take this, the negative part, it's just gonna be a negative thing instead, without attempting to solve it, right? So just this guy. Alright. And okay, just by preference, let me replace this guy with, I don't know, another letter. Let's do fuck this. Let me do a special letter. Row. Yeah, hell yeah. Let's quit this row. So let's make this row and row. Frick yes. Row your boat, leaving by the sea. Okay. Now what? Okay. Yeah. Let's do this thing here. Let's simplify that. Oh yeah. I'm just gonna simplify this. It's gonna be c squared 1 plus this guy. This becomes secant squared a. This becomes c secant a. And these two guys cancel out, and this becomes c secant cubed a. I hope. Okay, and we put the C on the back. Real horror show, and that's the expression. Don't mind that. That's me being me. Okay, and we are back to this, ladies and gentlemen. We're back to this thing here. Shit. Do I remember what this is? Oh. Okay, I think I remember it. Something like secant x, tangent of x, minus something involving the secant. And do we want to solve for this again? Do we want to do the whole process once more, guys? Is this right? Oh shit. Put it here. Okay, this is incorrect. I think I just have the signs wrong. Okay. It's this guy here. So this entire thing is the integral of secant. I mean, we have a choice of doing this again or just sticking with what we had. You know what, for the sake of time, I mean, do I have time? I don't know. What's the concept of time anyway? That came out of nowhere. Okay, let's use this formula over here. Alright, so let's see. So what I want to do is okay, C times this business over here, and we do the bounds for this guy. Right? Oh shoot! I want to click this part here. Okay, and then minus the entire thing. And replace this with the row, negative row, negative row, negative row, negative row. Okay, we're still on the same number. And you know what? Technically, we can stop here. And hey, we're done. We have we don't have any x's, no integrals. We're done. You know, you can just. Yeah, you can decide to edit here and there. Let's just hope that your math teacher can accept this bullshit of an answer. Well, to some it may be bullshit, but hey, okay. Now let's solve for each of these. What's the secant of row? That's the tangent of row, right? That's just a number, right? Secant. And row is this business over here. And oh boy. Hold up. Let me try to solve this off screen. Ah, freaking hell. So I'm just gonna imagine. I don't know, do I have to explain how to evaluate this? Because this is just like without any visual detail. Draw a right triangle that represents an arc, represents like an angle, like with no. A right triangle with the opposite side of B and the adjacent with 2C. And now in your imaginary image, you take the Pythagorean theorem of this to find the hypotenuse, which is b squared plus 4c squared, square root all over. And holy shit, am I doing my own maths in my own head? Come on. Okay, since this is the SOHCAHTOA, okay, this is 2c. Alright, I didn't need paint for this, I think. Let me type this down. Okay, we just did the math. I just did the math in my head. Okay, thank you, brain, thank you. Very based. So it's just this guy. Okay, so that there is second of row. Okay, alright, what's second of negative row? This is just... I can just plug a number and see if it changes. No, it doesn't. Okay, fine. It's just this. I could solve for the negative, like, specifically to prove that it's the same thing, but... You know what? By decision, I'm just gonna plug this to... I'm not gonna solve for second negative p if I got the answer anyways. Okay. Tangent of rho. That's tangent of arctangent of v of 2c. That's... Okay, there's v of 2c. Either way. What's the... Actually, no. Let me do that again. Let me confirm that this is indeed v of 2c, right? If it were negative, it's negative. Okay. So some sine stuff is happening here. So secant is this guy, regardless of rho sign. So let me break this down. Break it down. So it's this, and this, and this, and this. Okay, and this guy here. Okay, this varies by sign, so this, and okay, this, but there's negative. This, but it's negative. Okay, cool. And we have, holy shit, look at this. Look at this, man. Oh, holy shit. Okay, anyways. While we're at it, let me simplify this. Let me factor 1/2. All of these must have a factor. No, hold on. Let me bring a file down just in case I make a mistake. Let me remove the halves. Get all those 1/2s out. Very cool. Can I remove this? No, I can't. Okay, so this is gonna be 4c squared. Alright. Nope. Plus this guy gonna be 4c squared. Okay, at this point, it's just pure algebra, right? We've done the calculus, we've done the integration. All we have to do is simplify this, which is... Well, I think the math teacher told me that the hardest parts of calculus is the algebra part, ironically. The integration is just like, you know, you just have to know it. And then algebra, no, that's a big fuck you to the course. With all due respect, you know, with all due respect. Okay, so this is, I'm having quadratic equation vibes from this. Just because I did some certain substitutions of this. But yeah, let's see if I can you see plus 2cb and plus 4c. Wait, what am I doing? I'm just simplifying this algebraically. So this, alright, minus b. Okay. The oh god, the parentheses is messing me up. So it's this. Okay, this is one parentheses. This is another. Okay, what if I just remove this and remove that and do this and do that plus this? Okay, cool. What if I remove this business here? Okay, it remains the same. These here, these parentheses are important. Okay, this mode does not recognize like just pure absolute value signs inside. You need the parentheses for that. Okay, now what? Oh, look at this. We have. Let me put this thing beside here. So we have two of the same thing. So I just put two in there and then delete that thing. And here, well, let me tell you what. Let's do this. Okay, let me. Okay, same thing. So we have this business here. Okay, well the two C's cancel out, it seems. And we have this. I don't know if you can simplify this bit further, but bruh. Okay, well, all I have left is just distribute the 1/2 in the C, right? 1/2 times C. The one of the C's cancel out, and the two get rid of itself. Okay, we have this, and hell yeah, look, hold on. C is equal to b squared plus 8h, right? So we fuck that up. Why did I say fuck that up? Okay, but do this, alright? Do this, and then do this. Just gonna be the same shit. Okay. We still have more simplifications to do. Okay, so all right. More algebra, guys. Let's go. It's gonna be a B here. Then 8h carries over to the numerator. It's gonna be a 4h over here. Okay, I did something wrong. Oh, it's gonna be the 16h. Made a mistake. Okay. This is gonna become a 2. Okay. Okay. This is a good banger. Before and 64h squared. Before 64h squared. Okay, so far so good. This 4 is gonna be 16. Alright. Okay, so hey, we can factor b squared. Outside the square root is gonna be 1 and b squared. Okay, and this guy cancels out. Okay, let me keep this as is for now. And what else? Let me do this for a bit. 16h squared, 16h squared. Okay. If I factor the 16h squared, it's gonna be this, this, and these two cancel. Okay. And this guy carries over. Okay, I meant to do something with these square roots. That. Okay. So you know this guy here, right? This is the same thing as these two. And so far I have. What's the right word for? Is it the same thing as this guy? Okay, let me parenthesize this. Let me know what I'm doing. So 1b squared. Okay, I did something illegal. somewhere. This is be here. Okay, it's that. So this, I think, becomes this, right? Yeah. Okay, let's leave it at that. As that. Okay. Now I do the 16h squared again. Okay. And I want to multiply the 16h squared on both of these. And okay, this guy just cancels. And there's this 16h squared, that's just 4h outside. Gotcha. Okay, I think this is still the same thing over here, right? Yeah. Okay, the B cancels out, I think. Ah, fuck that. Fuck the B. Get out. Alright. H here, the 2H, it's gonna be 1, and then it's gonna be a 2. Okay. Okay, we can factor a B here, surprisingly. Boop. 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 Okay, just to confirm. Okay, no, you can't. Something sussy about this B here. Okay. B1. Yeah. Should be doing it like this. I'm factoring out B. Hell yeah, okay. Okay, I can formally recognize the cancellation of these two B's. Finally, okay. It's this. Okay. I have 1/4h on each of these. Let's say let's multiply 4h on both of these. On 4h. Okay. This guy dies. This guy also dies. This princess dies. And well. Is there anything else we can do here? Okay. Can we do anything else here? Okay, let me do this. 4h. Do the 4h. It's gonna be. Let me try this for a bit. Okay, and do the same thing for this guy. Okay. Then do this. Okay. Let's cancel this guy and cancel this guy. Alright. How about this guy then? What about this? Let me do it for this guy. Excuse me. 4h. Okay, what was this? H squared. Not 22h squared. Wait, what? What is this? Am I drunk or something? What am I doing wrong here? 1 plus... Rewind. Okay. Huh? 4h. 1 plus 16h squared. Okay, I'm doing something bad here. Okay. Do this properly. I tend to skip steps so I know what I'm doing, but oftentimes it fucks you up. Okay. Okay. Okay, something is happening with... Oh, no, hold on. No? No. Okay. Do it like this. There we go. And vector of 4h. Now this. And okay, I think this is just gonna be this expression here. Yeah. It's gonna be 2h. Okay, we can. Alright, now we have an expression for the arc length of a parabola of any base and a height. God dang. Okay, look at this. Let me copy this down. Okay. Oh shit, is my window that, like, compressed all the entire time? Oh man. Okay. Unprepared stream excuse. Unleash. Okay, let me zoom things in. Okay. So we have, let's see. So we have this entire process. And we end up with this. Okay, this is the entire process. How many steps did that take? Probably like more than 23. I just did some algebra that could have been some their individual steps. But like, just a random sound. Don't mind that. Okay, so we have this. Sure. And we're done, I think. Okay, it's let me put this thing as well to confirm it's true. Okay, we have arc length of a parabola. Okay, there we go. And hey, you know what? Let me look up arc length of a parabola. I saw an equation earlier on the net, and okay, I got the PDF for it. Okay, arc length of a parabola, arc length of a parabola. There's an image for it. I'm just talking to myself at this point. It's over here. Save image as. Stop image. By the way, I am using OBS for this, and I think image putting, whatever it is, putting an image is different than XSplit and OBS, I think. And I think XSplit is easier, I think. I've heard some other streamers that's like, yeah, XSplit is easier. What's this guy here? Let's see. So let me compare this. So it's this guy here. This is by base and height. So you can see here. The arc length of a segment parabola is given by... We have a direct comparison, guys. Look at this. Okay. Huh. It's vaguely... Huh. It seems like we can simplify this even more, right? Huh, okay. So what's happening here? I think this is correct based on the circumstances, right? But, okay. I'm still, like, adamant this is, like, the same thing. Okay, sure, what if we, Okay, what if we write it that way, you know? What if we write it that way? God, I need to constantly reference this thing. Okay, so A is the base. H is the thing. Plus 4h squared. Okay. plus b squared over 2h ln. Do we even need like? No, we don't need the absolute value. Okay, it's just that. H over a 2h over b. Plus square root of 2h over a squared. 2h over b squared. Okay, plus 1. The plus 1. Okay. Is that it? A squared was 4h squared to a squared 2h plus 1. Huh. Seems like it's different from this guy here. What? If I do this a minus? No. It's from negative b halves. What's our b? Or is this like assuming that? Oh, okay. This assumes that b is just like the 1/2 of it. Right. So if I do whenever there's a b, we add a. Let me do like this. B over 2. Hold on. There's a certain setup for this. So in this diagram here, like the A is, what is it? A equals B over 2. B over 2. So let B be B over 2. Okay. Let me do a copy pasting field for this. Okay. So this to that, to that, to that, to that. Okay. There we go. Same thing. It's just that A is just half of the thing. Okay. Very cool. I'm not gonna freaking simplify this. I have my own answer, my original answer. Yeah, I think I'm satisfied with how this came out. Okay. Hell yeah. I think I'm gonna leave it here for now. I think I enjoyed streaming. I had at least 90 minutes of alone time for streaming because usually this freaking apartment is noisy and full of, bad environment. Yeah, I was thinking of something else. What was I gonna do? Let me save this. Oh yeah, check out my comic series. I'm currently making like a comic series. Like drawings, drawings and comics. And I think I'm gonna put it on the description, I think. And the name is called, I don't know. Let me try to figure out how to advertise my comics for you. Hold on. I will leave it in the description, but I want to at least. Yeah. Put this here. Boop. Okay. Here's the link here. Let's see. That's the link here. That's the link of my comic series that I'm working on. So how it works is like you'll see my most recent comic that is published, and let me do an exclusive offer for you of what it looks like. Let me save this image here. God, I'm dumping my entire desktop with screenshots, just trying to Okay. Let me. What's the right layer for this? Okay. Properties. Browse. It's not okay. So here's open feature. Okay. So this is a run. Oh god, this is big. Oh yeah, let me take some time to minimize this. Hi. Useless quest. What could this be? What could this be? Okay. Dear God, come on, OBS, be cooperative, please. Just look, I'm trying to minimize by the handlebar and the shit. Yeah, it's gonna take some time. So just watch me like scale this thing down. But okay, Dick's the comic series.com is the name. I think I'll put in the description, whatever. Okay, so in this today's strip, I've written about presuppositions. That's a title, and I'm just drawing in my own imagination. So you just have like a froggy chair. You have Dia here and some Empress fella here. Pokemon. I just like Pokemon, man. Lately I've been drawing a lot of Pokemon comics also, but that'll be for another discussion. But also pardon background noise, but yeah. I don't know if you want to read this. This is like a long one. I don't know if this can fit to the resolution, but yeah. Here it is. Here's a feature of what it looks like. I post like almost every day. I will post one like later on, but yeah, here we go. Dick's the comicseries.com. That's a wait, it's the comic title is Dick's, meaning Dia's idiosyncratic comics and comedy with a K and stuff. It's yeah. That's all I have to say for this stream, and thank you for watching me become a nerd for 90 minutes straight, and I'll see you guys in, I don't know, whenever I decide to. Yeah, I'll see